Okay, this is the corrections video for the functions test. I'm going to go through this really quickly. If you need to, just pause it. It says, which ordered pair belongs to the function shown by the mapping? Alright, so y'all, 7 is mapped to 3. 8 is mapped to 1. I can tell this by the arrows. 9 is also mapped to 1. And 10 is mapped to 2. So the one that belongs is that one. None of these are in the mapping. Number 2, which statement compares the data on these graphs? Y'all, this has been on a test that we've already had before. Graph M and graph N. The word linear. Linear simply means that it makes a line. So both graphs are linear. I see a line here, but that's not a line. Neither graph is linear. No, this one makes a line. M is linear. Yes. N is not. That is true. Which relation represents a function? Remember, function is where the x's don't repeat. Here, the 4 repeats because it's got 2 arrows coming out of it. I have 4 paired with 11 and 4 paired with 12. Alright? B is not a function because if I pass a vertical line right there, I'm going to touch 2 points. Doesn't pass the vertical line test. Okay? C. If I circle all of my x values, none of the ones that I circled are repeating. So the x does not repeat. This is the function. This one is not a function because the 2's repeat. So no, no, and no. C is the answer. Next. Number 4, which set of ordered pairs represents the information in the graph? It's just asking you what the coordinates of these points are. This point is at 1, 4. This one is at 2, 6. This one is at 3, 10. And this one is at 4, 12. 1, 4, 2, 6, 3, 10. Right there. Number 5, which relation does not represent a function? So I'm looking for the one that does have repeats. X will repeat because it's not a function. So if I'm looking at this, all of these, there's no repeats. That is a function. Here, look at this. The ones repeat. So that is not a function. This is the one that I want. But let's just double check. 1, 2, 3, and 4. No repeats. That is a function. Vertical line, vertical line, vertical line, vertical line. This one passes the vertical line test. So it is a function. Moving on. Number 6, which mapping represents a function? That means for mappings, that means that only one line can come out of each number. So look, I don't care what's happening over here with that 3. There is only one line coming out of each number. This is the function because there's no repeating x value. This one is out because the 8 has 3 lines coming out of it. 8 is repeating. And so is the 9, for that matter. 9 is repeating. You've got 8, 3. 8 is also paired with 4. 8 is also paired with 9. 9 is paired with 3 and it's also paired with 6. Look at all that repeating. Here, the 1 is repeating. 1 is paired with 1, and 1 is paired with 3. Look at this one. The 1 is repeating again. 1 is paired with 1, and 1 is paired with 2. These are not functions. Number 7. Which relation is a function? Nope. 2 points touching the vertical line doesn't pass vertical line test. So it is not a function. Circle all your x's. Look, none of them repeat. No repeats. So this is the function. This does not pass the vertical line test. Neither one of them do. Look at this. Circle all your x's. Look at those repeating 2's. The 2's repeat. So it is not a function. Number 8. Given the mapping, what is the domain? Domain means the x values. Hey y'all, this is the x, this is the y. There's my domain. 4, 8, 12, and 16. That is a vocabulary question. Number 9. Given the graph, which point does not represent this function? This simply means which point isn't on the graph. 295 is right there. 995, I go over to the 9 and up to the 95, it's right there. 580, I go over to the 5 and up to the 80, it's right there. But 1190, I go over to the 11 and up to the 90, it's right there. That is the one that is not represented on the graph. Number 10, given the graph, what is the range? This means your y values. Okay, the coordinates of this point are at 1, 2. The coordinates of this point are at 2, 2. The coordinates of this point are at 3, 3. And the coordinates of this point are at 4, 4. Y values. That means my second number. That means this 2, this 2, this 3, and this 4, but you don't list, when you're doing sets of numbers, you don't list them twice. So I've got a 2, but I'm only going to list it once, a 3 and a 4. 2, 3, and 4. You only list numbers once in the set. No duplicates. So my range is this 2, the 3, and the 4. Number 11. Given the ordered pairs, what is not true about this relation? First of all, I'm going to circle my x's. And I see that I have no repeats in the x values. So that means that it is a function. I want the one that's not true. This is true. The second thing that I notice is that this thing goes through 0, 0. Guess what? That means it's proportional. That is true. Linear or nonlinear? Compare, look, what do I have to do? Let's do this. 2, 4, 2, 4, 8. Actually, you know what I'm going to do? I'm going to put it in a table. For 8, 6, 12, 8, 16. Y'all look at this. times 2 times 2 times 2 times 2. That makes it proportional. I can also say it's linear because of my change in y over my change in x. This is going up by 4. This is going up by 2. This is going up by 4. This is going up by 2. This is going up by 4. This is going up by 2. My change in y over my change in x always equals 4 over 2, which equals 2. This thing is linear. The one that's, whoops, that's true, so the one that's not true would be D, nonlinear. Number 12, which graph is not a function? The one that doesn't pass the vertical line test is this one right here. If I put a vertical line through here, I'm going to touch that V shape in 2 different places. So this is the one that is not a function. This one passes the vertical line test. No matter where I draw a vertical line through it, I'm only hitting that jagged line the one time. Same thing here. Vertical line, vertical line, vertical line, vertical line, vertical line. No matter where I draw that vertical line, I'm only touching that upside down V in one spot. Same thing here. Vertical line, vertical line, vertical line, vertical line. Doesn't matter where I draw that vertical line, I'm only touching this U shape in one spot. Vertical line test. A function is when the x values are all different. Guys, the x can't repeat. That means they all have to be different. Number 14, which graph is a function? This is the same vertical line test. 3 of them are not functions. This one is not a function. Look, if I put a vertical line right there, I'm touching that square 2 places. If I put a vertical line here, I'm touching this sideways U 2 places. Not. If I put a vertical line here, I'm touching this oval 2 different places. This is not a function. This is the one that is. No matter where I put a vertical line through this jagged line, I can only touch it one time. This has to do with the vertical line test again. Number 15, which table belongs to the function? This is your input and output stuff. If you input a 1 into this equation, 3 times 1 plus 6 equals 9. Input a 2. 3 times 2 plus 6. 6 plus 6 is 12. Input a 3. 3 times 3 plus 6. This is 9 plus 6. That is 15. This is the correct answer. Number 16. I think it's this one. I'll just do them down here. Yeah, I think it's this one. If I input a -1 squared plus 5 equals -1 times -1 is +1. 1 plus 5 is 6. Input a 0. 0 squared is 0 plus 5 is 5. Input a 1. 1 squared plus 5. 1 times 1 is 1 plus 5 is 6. This is the correct answer. Number 17. I can't remember which one it is. I think it's this one. Let's input a 0. So 0 squared plus 2 times 0. Oh, no, it's not that one. So, nope, because that would equal 0. Let's try. Which one is it? try this one. Negative 1 squared plus 2 times negative 1. So negative 1 squared is 1 plus 2 times negative 1. 2 times negative 1 is negative 2. That one doesn't work either. Let's try this one. Let's input a negative 2 squared plus 2 times negative 2. Negative 2 times negative 2 is 4, plus 2 times negative 2 is negative 4. 4 plus negative 2, 4 plus negative 4 is 0. Let's input here. We've got negative 1 squared, which is 1 plus 2 times negative 1. So 1 plus negative 2, that would equal negative 1. And then if we input a 0, 0 squared plus 2 times 0 equals 0. D would be the correct answer. Number 18, which function is linear? Linear, see, we talked about in class, if it's non-linear, you're going to see an exponent. That was the big takeaway from Tuesday's lesson. Wrote it down. I said if it's non-linear, then you will see an exponent. So the one that is linear will have no exponent. So I'm just looking for the equation with no exponent. This one has an exponent, this one has an exponent. Oh, that one does not. This one was out. Which of the following sets is a function? So I'm going to circle all of my x values, and if anything repeats, that's not a function. Circle all of my x values. If anything repeats, that's not a function. Circle all of my x values. If anything repeats, not a function. Here we've got 1, 3, 4, and 9. Nothing repeats. That's a function. Okay, which one is linear? Which one is a linear function? They're all functions. It's telling me they're functions. This has to do with the proportional and non-proportional unit. It's kind of a throwback. And if you'll remember, we did the peaks when we were given a table. Change in y over change in x. So this is plus 6 here. And 9 to 14 is plus 5, plus 2, plus 4. 6 over 2, whoops, why did I write 6? 6 over 2 and 5 over 4. These are not equal. This is not the one. This is plus 3, this is plus 5, this is plus 1, and this is plus 1. So 3 over 1 and 5 over 1, those are not equal. Remember, it's change in y over change in x. That's what I'm doing every time. Plus 3, this is plus 6, this is plus 2, and this is plus 2. So you've got 3 over 2 and 6 over 2. Those are not equal. Alright, this is plus 5, this is plus 3, this is plus 5, this is plus 3. So you've got 5 over 3 equals 5 over 3. Ta-da! There's the one.